All right, welcome everyone. Thank you so much for joining us for our second session in the AIA California Monterey Design Conference University Series. My name is Hillary Kreck, and I am the Director of Programs for AIA California, and I will be your moderator for today's segment. This morning's presentation is brought to you by Build with Strength, National Ready Mixed Concrete Association, California Nevada Cement Association, and California Construction and Industrial Materials, who are our presenting partners for the 2021 Monterey Design Conference. If you haven't yet signed up, it's not too late to join us. MDC is coming to you on the road this year, wherever you are. The virtual format is our way of inviting you to see what makes the Monterey Design Conference the Architects Retreat and why we have so many loyal fans, or many loyal attendees. Our headliner speakers this year will join us from Portugal, Japan, England, Boston, and of course, California. Clear your calendar next week, October 21st and 22nd, and carve out time to focus on these amazing architects and how their work is shaping the world. More details of our amazing lineup of speakers and registration are available online at montereydesignconference.org. A few quick housekeeping reminders before we get started. Please use the Q&A function to ask any questions for today's presenter. You can also like a question to move it to the top of the queue. Today's session qualifies for one AIA learning unit. For those of you watching live, AIA California staff will report your attendance for you shortly after the session. Today's session is also being recorded and will be posted on the AIA California website later this afternoon. Now on to today's session. Tilt up is a method of construction whereby large concrete panels are cast on site and then raised into position with a crane. The building system, which was conceptualized in the early 1900s, is used throughout North America and across the globe. Once considered a method suitable only for large warehouses, today, tilt-up construction is the method of choice for many developers, designers, and contractors because of its numerous benefits. It is employed on virtually every building type, from distribution centers to schools, churches, libraries, retail centers, and office buildings. This session will present the latest advances in tilt-up concrete technology to provide economical, energy efficient, and durable building solutions. I would like to introduce today's presenter before getting started. Mitch Bloomquist serves as Executive Director for the Tilt-Up Concrete Association, also TCA. Managing day-to-day operations of the association, Mitch is responsible for a wide array of publications, events, membership committees, association programming, communications, and brand management. Since joining the TCA in 2010, Mitch has led the production of a trilogy of state-of-the-art resources for the industry, including the construction of tilt-up, the architecture of tilt-up, and newly published engineering tilt-up. Mitch also contributes to and oversees the production of TCA's flagship publication, Tilt-Up Today. His writing has been published in Tilt-Up Today, Concrete Construction, Concrete International, Concrete Contractor, the Construction Specifier, and other trade publication. Mitch graduated with honors in 2004 from Cornell College in Mount Vernon, Iowa, where he studied art and music. In 2007, he received his Master of Architecture from the Graduate School of Architecture and Urban Design at Washington University in St. Louis. While at Washington University, Mitch was named Windman nominee, recognizing him as one of the top graduate students. So with that, take it away, Mitch.
All right, thanks. Get this presentation up. All right. Well, again, thanks for the invitation, and thank you very much for attending. I've got a presentation today, New Generation of Tilt-Up Buildings is how it's titled, and we're going to go through some brief history of the method, a brief accounting for the kind of technical side of it, and then move into some architectural case studies. So I'll start off from the beginning. So if we're saying a new generation, it's helpful to see, what other generations there have been. The method of construction, tilt-up method of construction, was invented for military purposes back in 1906 in Ohio. Here you can see Colonel Robert Aiken and their crew building these military buildings back a long time ago. Thomas Edison discussed tilt-up briefly as a very efficient way to build a concrete wall without building two wooden walls, but didn't have more than that. He just kind of noted it in its very early stages. He did work a lot with concrete and did some interesting things and had that comment on tilt. It wasn't until 1913, though, 1914, that Irving Gill kind of engaged as architecture formally with the La Jolla Women's Club. And so I understand you guys are in California, not completely Southern California, but you're probably, I've got a lot of California projects in here, just so perhaps you'd be familiar with them, and that would be beneficial. So Irving Gill, 1913, 1914 with the La Jolla Women's Club, and then just a little bit later, Rudolph Schindler, I'm just going to move this little window here, Rudolph Schindler with the King's Roadhouse in 1922. So after that, the technology was sort of kind of kicked to the side for World War II, and everything was put towards those efforts. And then after the war, it came roaring back and supported the suburban growth post-war. One of the main things that allowed it to do so was the mobile crane. And so you saw it being used to build, this technology being used throughout California, actually. I often talk about, California thinks they invented tilt-up. It was invented in Ohio, as I said, but it really grew up in California. So all of the big boxed warehouses that you see throughout your landscape, many of them are tilt, and they were built in that, they started to really boom in that post-war suburban expansion. Now, what you end up with is a lot of this, these single-story big box buildings without many windows. And it's really how tilt got that early stigma of this building, this big box building. So you see where it started. It started as a military invention. Thomas Edison's talking about it. Irving Gill's using it. Rudolph Schindler's using it. And then its progress was really disrupted by World War II, and during that time, the technology that had allowed it to continue moved it into a place where it was very economical and efficient. And it was used to build these big box buildings. So it kind of got stuck in that piece for a long time. Stephen Hall was not the first one to re-engage it as architecture, but certainly these are projects that you probably know, projects that you've seen and probably like maybe. But 1997, the Chapel of St. Ignatius, these projects were completely tilted as far as, and I say that meaning the details and the design was very authentic and very intrinsic to the method. You still see the little places where the caps or the lifting inserts were on, and we'll learn about those in a minute, but you see those things. Then much later, well, a while later, he did a house in Paradise Valley, 2005. Again, very interesting panel shapes, really interesting connection details and joint details. And again, you see kind of the hardware there. So those projects really celebrated the method, really showed off what it was all about and what it could do. But they never really, launched a movement. I think Stephen Hall did another tilt house in New York as well, but there were others that were doing this at the time, and it was gaining a lot of steam, or it failed to gain a lot of steam, but other architects were engaging it. As they did, they began to do very unique things, and some of those things we'll look at today. But to be creative in any medium, you first kind of have to understand it. So I'm going to take a few minutes to go through the construction process itself, so you have a basic understanding of how it works. I'm sure you're familiar with it and you've seen it, but knowing this kind of allows you to see the potential for what could be done and how they were able to do these things in these projects I'll show you. So a lot of people think it's got to be a flat site, a large open flat site. Many of the projects we'll look at today were on, urban sites or tight sites or infill sites. So, certainly needs to be level, and it needs to be, you have to consider crane access and the equipment that needs to come in and out, but that's the same with any job site. So They prepare the site, they lay down a casting slab. So the casting slab is where the panels will be made. So if you're super unfamiliar with tilt-up concrete, these are panels, concrete wall panels that are cast on site. So it is technically a form of precast construction. The difference from the plant cast precast that you're used to maybe, or that you associate more regularly with precast, is just that they're cast on site. And so this casting slab right here happens to be the building slab itself. It could be a recyclable casting slab that you use that is not the building slab, but either way, they're using a laser screed right here to build this casting slab. Here you see the panels. This is all the same project I'll take you through just to see the process. Panels are formed up using just dimensional lumber on a concrete slab, very simple, very accessible. There you see those being formed. They're tying their reinforcement. I'm going to drop the steel in. You see that in. Concrete's placed by a pump usually. So they pump in the concrete. It's placed into the panels. You see some few other things tied in there, some steel embeds, lifting inserts. It takes, pretty much the next morning, they'll strip the forms and begin to attach any kind of plates, steel plates or embeds or things that are going, or not embeds, but they'll touch steel plates and things that go on the outside of the panels. Safety meeting before they start lifting them. You make sure the site's clear. And again, I'm skipping through this fast. If you have questions about this stuff specifically after the seminar, I'm happy to run through, any specifics you want. This is probably a 2250 crawler crane. It's pretty typical. They want to be able to move around the site with the panels. So instead of using a crane that's got outriggers and needs to be stationary, they often use cranes that can move around the job site. The panels are connected to cables from the crane that have, like we talked about earlier, there's inserts cast into the panels. There's clutches that connect to those inserts and they lift up. I've got a chat question just to make sure. Okay, which issue hit. All right, so once the crane's connected and they do one last review of make sure all the connections are secure and it is erected. So there you see a panel going up. These are 4-story panels. They're load-bearing structural panels. You can see some of the interior steel being erected behind them. They're set onto normally a continuous footing. You can see it kind of in this picture. I don't know if you can see my arrow or not, but there's little shim packs. They're little kind of plastic neoprene or 1/8 inch increment shims, basically. So they'll set them on those shims so that they can get it level perfectly. And there they go, setting that panel. And then there's braces that hold the panels temporarily until the entire structural diaphragm is connected. So here you see these braces are connected to that slab, the same slab that they were cast on. They're telescopic braces, so they can rotate and push and pull to get the panels perfectly plumb. These are helical anchors, so they're kind of, you can see these braces are anchored into the soil around the building. So, construction and engineering teams, design teams have the option to either brace to the inside of the building or brace to the outside of the building, depending on different site constraints or things that they want to have happen. Sometimes the bracing can get complex to the inside. With taller buildings, you see a lot of intersecting braces. So often these structures get braced to the outside to make that free, and then they can start erecting steel on the inside while they're still braced. Here's the steel package going up. Some connections being made, finishing touches, cleanup of the panels, and there's that finished building. So that's the building that we just kind of walked through. The construction of that's an Express Scripts office building in St. Louis, Missouri. So this is usually the point where I ask the audience, what are the benefits of tilt-up? Are you aware of them? And it's kind of hard to do that virtually, but if you want to throw a benefit in the chat, that's great. But the one most people think of is size of panel, right? So the panels can be large. And we talked a minute previously about the difference between precast and tilt-up or plant cast and site cast. And one of the major differences is the size restriction. So these panels don't have to be loaded on a truck. They don't have to go around curves and through tunnels, so they can be very large. The only limitation to their size really is one, the crane that's available to lift it, and two, the bracing that's available. So this is an 89-foot wide panel. It's the widest panel on the planet right now for tilt. It was at a charter school in North Carolina. You can see that panel being erected. There it is going up. Kind of, you can see the people and gives you some scale there. But so the panels can be very wide. They can also be very tall. This is a 111-foot, 9-inch tall panel in Miami, Florida. This is a dormitory that it's going on to. These panels in this application are not structural. They're not load bearing. They bear their own weight, but they're not part of the structural system for the building. You can see the cast in place concrete frame behind it, and these are cladding panels. Before they could do this, they often just used kind of a block infill and then stuccoed over them. But a lot of the dormitories, hotels, hospitals, things like that are multi-story are going to a tilt cladding. 111 feet tall. That's the tallest tilt panel right now in the country or in the world. There you can see it being lifted. So you see there's edge picks on the top of it. That's so that once these little, the anchors on top, the lifting anchors on top, that's so that once the panel's up in the air, they can transfer the load to those so it hangs perfectly up and down, so that they can get it right up against the building. So there's another shot of the building. So they also do stacked panels, so they can make smaller panels and stack them up. That's very much like plant precast, but these panels can be a little larger. If you're in a market where you have tilt on the job site or you have big cranes, things like that, a lot of times they'll do this where they can stack them. Again, these aren't load bearing in this application. This was for a hotel also in Miami. You see them flying them up to the building. There's the building under construction. So one of the things that happened, fairly recently in Texas is that, and Texas is a very, very successful tilt-up market. It's a very mature market where there's a lot of innovation. Florida has a lot of innovation as far as aesthetics and finishing. Texas has innovated quite a bit with the structural pieces. So these are load-bearing panels. There are no perimeter columns or anything like that. These are completely load-bearing, part of the structural system. It's a 4-story panel with a 2-story panel stacked on top of it. So you can kind of see how their alignment and their kind of structural lines have shifted at the top. That's intentional. You can see the big openings at the corners that have no columns or anything like that. They're truly cantilevered openings. Here, I have no idea why this picture looks so old. It's not old. I don't know if the architect thought the black and white looked good or whatever, but you can see the 2-story panels being installed on top of the 4-story panels. And I think I have another one. So these are braced back to that floor there and put on top. So there's the building. That's, like I said, that's a fairly new development as far as them being load bearing. It's been 5, 6, 7, 8 years now, but these projects have gone from 4, 5, 6, 7, 8 stories tall. So again, the benefits of tilt up, and we're going to go through these case studies and discuss kind of how the different benefits applied and how the different benefits move these projects to tilt. And we started by talking about size. So the size of the panel is one of the main benefits of tilt up, but that has other implications. Again, it's the size of the panel is why it was so successful in constructing these big box buildings all over the country. When you have a larger panel, usually things are quicker. So tilt up is known for being quicker. Okay, it's faster construction. When you have larger panels, you have fewer joints. So it's a tighter building. There's less joint maintenance. It's easier to maintain in the long run there and less costly. Another benefit with the size of the panels and their on-site construction is that the schedule is often, the contractor has greater control over the schedule. They're not waiting on delivery of anything from somewhere else. They're not, at the mercy of some plant somewhere. So that's another one of the benefits of tilt that cause it to be faster, that cause it to be a great solution for these big box buildings. So you get these, you see them not real interesting, but incredibly efficient. So then it takes us to kind of our first case study. And these, I say case study, really, I'm just going to talk about some projects quickly to get through a lot of them. But the Marine Corps Support Facility in New Orleans, Louisiana. I've got a video. I will play it. It's only 2 minutes long, and it's just the owner at the ribbon cutting talking about the facility, and he goes on about tilt and how it was used and why it was used. And I'll play it real quick because it covers a lot of the benefits of the method are kind of encapsulated in this quick talk. So I'll play it quickly for you guys.
On behalf of our Federal City Project team, I'd like to thank this large audience for joining us on this warm morning to celebrate this wonderful occasion for Louisiana, New Orleans, and the Marine Corps. It is with particular satisfaction that the Federal City team stands in front of you today, delivering the first down payment in one of Louisiana's biggest economic development projects. And we're doing this 2.5 months ahead of schedule, well under budget, and with a superb quality that is evident to the eye and reinforced by the enthusiastic response from the Marines who have just moved into this new headquarters facility. Although we broke ground in September of 2008, serious construction did not begin until April 2009. Finishing construction on a 411,000 square foot facility and a 29-acre secure compound before the BRAC mandated completion deadlines in the late summer of 2011 was problematic. Our design builder, Carly Woodward, made a bold decision to use tilt wall construction on the Marco Res headquarters building. If this new technique works, it would lead to a building that was built better, faster, and cheaper. In this tilt wall construction, the massive outer concrete walls of the building were framed and poured on this very site. A huge crane lifted these wall segments into place, and they were bolted together. This building was built from the outside in and from the top down, just the opposite from normal building techniques. It all worked perfectly, and now as you see before you, the biggest tilt wall constructed building in the South and the largest tilt wall building in all of DoD. It's also noteworthy to report that on this mammoth construction project, there was not even one significant injury by any other workmen. Likewise, our design team, Carly Woodward, and their subcontractors, led by Woodward President Paul Flower and Executives Steve Lawson and Bob Liston, deserve great accolades for their exemplary work on all the Federal City project and their flawless execution of the aforementioned tilt wall construction technique. Our construction team did not treat this as a regular job, but rather took on the mission to build something very special for the Marines, and they succeeded.
All right, so you get it. But I thought it was really interesting because so you're going to hear a couple of these stories today in this talk where a project was not going to happen for various reasons. Projects stall because of cost, they stall because of schedule, or something can't get done in time. And this was one of those. So he goes on about tilt construction. He talks about the cost, he talks about the schedule, he talks about the beauty of it, the durability of it, the safety of it. So he really covers all these benefits of tilt in one kind of thank you speech or opening remarks. And you don't really hear that very often. I don't think. You don't go to these ribbon cutting ceremonies and hear about the construction technology. Nobody's ever like, oh, the metal panels really saved us on this project or anything like that. And for a few reasons. One is that I like to think of these buildings as being handcrafted, and they definitely are, and I'll demonstrate that and prove that out. But the system is one, right? So the what you see in the end is all part of the tilt-up system, whether it's something embedded, something a finish that's affected on the panel on the face of the panel. It's all part of the same tilt-up system. It's not all these different pieces coming together. And so what you see a lot in the market now and over the last 20 years is an assemblage of pieces and accessories and elements plucked from the kind of ads of Arc Record or Architect Magazine and then kind of applied to the building in an additive fashion. You end up with this. It's this building's right down the street from our office. It's a nice looking building, but when I look at it, what I see is tons of field verify, right? We're gonna order this thing. Hopefully they have it in the finish we want, and hopefully it's going to arrive on site when we want it to. Hopefully it's going to fit. Hopefully it's going to have all its pieces. Hopefully we can find it once it is on site. And just every single system on this building is an opportunity for a mistake, opportunity for a delay, opportunity for issues with availability, issues with finish, issues with fit. And that's one of the things that I think is so great about Tilt, is just the ability for the contractor to have control, and in a positive way from a schedule standpoint, positive way from a cost standpoint, and as you'll see, a very positive way from a aesthetic standpoint. So we've talked about schedule and time, and one of the ways it's fast is that a lot of the planning work, a lot of the preparation is done in a way that it's almost at its finished state before anything's put in concrete, before anything's finalized. So changing things is easy. Verifying things before anything is permanent is easy. All that stuff. So here, but it's done in a very rudimentary way. So here they are planning to make sure the panels will fit on the casting slabs and where they're going to go. There's obviously more sophisticated ways of doing that and showing the crane moving around the site. Like we talked before, it's 2x4, or it's dimensional lumber. It's out there with a tape measure, just measuring it, and you making sure it's going to be right, and you end up with your building. So schedule wise, we're going to get into our projects here. University of California, San Diego had a new hospital, I believe, and you guys are right. Not too far from there, at least it's in California. I understand it's Southern California, but so they were building this new hospital building, and they needed a new office building to support it, medical office building. And what they had planned to do, if you know that campus, it's got a very, very rich architectural history, architectural heritage. Their buildings are serious architecture. They take a great pride in their campus. But they needed this project quickly. They didn't really have it budgeted that much. And so what they were going to do is build these temporary classroom type office buildings. We see them all the time at schools around the Midwest, where a school doesn't have enough money to build an addition, but they need more classrooms. So they put these trailers out there. What they ended up with, when their facilities manager suggested they look into Tilt and those options, this is what they ended up with. Now, obviously, this was more expensive than that, right? I'm not saying at all that's what happened, that they were able to get this for the same price. But what did happen was they were able to see, you know what, we could spend, we have the amount of money we need to spend to get something, and we could get this out of Tilt in the schedule we need and under budget. And the design team at Gensler was able to show them that they could also get something that was aesthetically meaningful and something that could hold its own on that campus, that wasn't going to break the bank. So what they ended up doing was a very simple project. These are, we'll see throughout this presentation complexity. And one of the beautiful benefits with Tilt construction is that complexity doesn't necessarily come at a premium, right? So the way to affect the texture of these panels, the way to affect the kind of setbacks here is very simple, because it's cast just on the ground. So you can do a lot with a little in Tilt, and they did here. So they just have a variety of setbacks. They just put foam down or plywood down on the board. They have some form liner patterns there that give them different textures. They kind of dress up the corners and I hate even saying that because I think the whole thing's beautiful, but they put some glass corners on it, a beautiful entryway. There you can see the building from the interstate, and it's kind of a close-up on the sunshade devices they used, and a really successful project. So the school was very, very happy with it. They were incredibly impressed with Gensler and what they were able to do with their budget and their schedule and the product they got. It was very well received. And they decided, shoot, let's do it again. And so they built the Triton Ballpark using Tilt in 2014, again with Gensler. And they got the same result, same success they had. They were able to control costs. They were able to control schedule. They were able to have kind of unique custom aesthetics. They've got their logo embedded in concrete on the side of the building. They've got these unique textures, beautiful colors. And so in 2016, they hired Architects HGW, Hannah Gabriel's Well, to do their Spanos Athletic Center, again in La Jolla for UCSD. This project had other challenges. So they were in the middle of moving from, I think they were Division III to a D1 school. And they needed a Division I facility on a D3 budget, right? Because they were going to try to attract these Division I athletes. And so again, they went to Tilt. Concrete, again, is a very important material to that campus. And they had the budget they had and the schedule they had, and they were able to accomplish something, that they're very proud of. Here's the back. You can see these panels. These are single panels, but they've got this kind of shifting geometry to them. They've got overhangs, beautiful, roof structure, the articulation of the lights in the recesses of the panel. There's just so many simple things you can do that are very, very, very cost effective, but have huge impact. So one of the reasons they have a huge impact is the size of the panel, right? So you can make these large gestures, these large moves, and it has such an impact on the building. But again, at very little cost compared to just a regular solid panel. So great project. So now we'll move to St. Louis, Missouri, back to St. Louis, Missouri from the beginning. This is the Fine Arts, Palace Fine Arts, Fine Arts Center from the 1904 World's Fair. It was designed by Cass Gilbert. And the director in that team had hired David Chipperfield Architects out of London to create an addition to the building. They obviously had the opposite problem of UCSD or anywhere like that. Well, I guess UCSD has plenty of money, but they didn't have a money problem. They weren't looking for a cheap project. They weren't looking for a cheap solution. The schedule didn't really matter. They could take 10 years to build this thing. That didn't really matter. But tilt-up was still the answer. And one of the reasons they went to it was that they wanted something monumental. So they've got this massive Cass Gilbert building that's already been there for more than 100 years. It's got huge stone pieces. It looks like it's going to be there forever. And they didn't want the addition to be less than in that way, in the way of I would say resilience or timelessness. Okay. And so they wanted these huge, the design team had visited the Kunstmuseum in Liechtenstein, which is this, cast in place, dark concrete museum that's been polished. Now, if you look at the side, especially over here in the light, you can see the kind of oil canning type thing. So you can imagine them up there polishing a vertical surface is very difficult. And, the quality controls, you're not able to control the quality very well. It's a nice project, but it's not executed perfectly by any means. Now, concrete floors, they polish all the time and they look great. They have great consistency. It's efficient to do. The tools exist, the machines exist, and that's what they did in St. Louis. So our panels are already cast horizontally on the ground. The only thing they really did differently here is normally the side of the panel that's going to be outward facing is down. Here they just flipped it. So they have the outward facing side of the panel up, and they polished it like it was a floor. Now, the architect Julie Bauer was David Chipperfield's project manager for this project, and she moved and lived here for a while during this construction. She's actually now a visiting professor at WashU. She talked a lot about the incredible craftsmanship that was involved in this project, the jigs they would make, the tools they would use, and the touch of the hand on this project was so great. And she really, kind of echoed what I thought, that it was hand built. So here they are polishing these panels. They over poured them all so that they were kind of thicker than they needed to be. Obviously the mix is specialized. They have local aggregates. They've got color. They've got great control over the disbursement of aggregates in there. And you can see the Cass Gilbert building in the background, these panels being polished up front. Interestingly, if you're an architect, which a lot of you are, and you've worked with concrete, all the contractors want to put this bevel, right? This chamfer on all the panel edges. I hate them. They look bad. I don't, it's nice to have a crisp, clean edge. And so when the design team, and they worked with HOK was the architectural record for this project, and they came up with the idea with the contractors and to overpour the panels so that they were bigger than they needed to be. And then they would polish them. They didn't have to worry about chipping the corners or the edges. They didn't have to worry about spalling. They didn't have to worry about, rounding the edges or anything like that, because then after they were polished, they came through and they cut them out. Again, you're working horizontally. These are just floor slabs basically. And they come and they cut them to size. And so then you had these beautiful hard corners that were crisp and clean. You have this beautiful polished floor that's now going to become a wall. And that's just another photo of them finishing it. And then here's kind of the finished project, the finished wall sitting there by the original building. And you can see that crisp corner and how well it turned out. There's the finished project. Just a really nice project, beautiful project. I see questions in the Q&A. I'll take a look at them. We'll look at them at the end. If you do have something that you need earlier though, maybe you can chat or something. So the other thing to notice when we talked earlier about them wanting these monumental panels, so this stone is, this floor panel, this wall panel is huge here, and they've also added this large return on it. And so you've got this appearance of just these massive panels. You can see they're held, the detail of them being held off of the ground there at the bottom, and there's a recess back. So they really are beautiful, beautiful, large granite looking panels. Another project that we'll move to in Chicago, Illinois, it's a church project that was done out of tilt. It was done through the middle of winter. And so the big problem on this project that they moved to tilt for was the nasty Chicago weather during the winter. So this project was constructed in the record cold temps. I forget what year it was. I don't have it on there. Not too long ago. Lots of interesting stuff going on. You can see all the arced openings, the panel shapes, are curved. They're curved in elevation. They're curved in plan. Again, with this construction technology, there's not a lot of added cost for some of these things. This is a strong back they're putting on there. You can see the very thin piece of panel there. So they'll put that reinforcement on the panel while it's being lifted and then take it off. It's just to make sure it's not cracked or broken during the erection process. Here you can see this elevation on the ground as they're constructing it. Here you see too these panel returns, how the panels are turned up at the ends. You saw that on the museum project as well. Very complex. I mean, some are sitting on cast in place foundation walls, some are sitting on strip footings. They're braced to the inside, the outside. I mean, there's all kinds of stuff going on in this very complex project. And then they ended up, matching sorry, I should have mentioned that earlier, but it's an addition to an existing church. And they were able to lay the same exact stone that was laid in front of the old one, in front of the new one. And again, it happened within budget, within schedule, and the look and durability is exactly what they were looking for. So looking better with time, this is a project in South Carolina. It's another church, but it's a project I got to visit not too long ago. And when I visited it, I was used to looking at these pictures of it. So it looks brand new in these pictures. But honestly, when I visited it, it looked better than it does here. And I think, good quality stuff does that. So if you're not spending all your maintenance budget on repairing stuff and replacing sealants and fixing things, you can spend it on upkeeping the pavement, the landscaping, the paint, things like that. And so well built, well designed, good materials tend to look good over time. They don't continue to deteriorate, and they're cost effectively maintained and maintained. So I thought that was interesting. But on this project, they used a tabby stucco. These are oyster shells laid in a sand bed with concrete then placed over the top of it. I've mentioned handmade, you get it, but what they did is they involved the congregation in laying these oyster shells into this sand bed. So the contractor put down the sand. They had these boxes of oyster shells, these buckets of oyster shells, and the congregation would go around and they would place them all as a group. And it was a way for them to all get involved in the process. Interestingly, if you had one person placing in one area for too long, they saw in the mock-up panels that the way that person placed the oyster shells was specific enough that the building would look blotchy from the outside if you let any one person work in one area too long. So what they had was they had a little timer, and they would rotate positions every 5 minutes or whatever it was, so that it was a uniform look to it. So there wasn't, here's this section done by Johnny and here's this section done by Sue. It was all mixed together. So really kind of a nice thought that the hand is that impactful in the construction of these projects. Incredible detailing around the openings, lots of opportunity for interesting custom stuff that, again, it's wood strips glued down or PVC strips glued down to a slab, and then you're going to just pour concrete over it. Not incredibly expensive. Here's another picture of the finished project. So we'll move on. The fluidity of concrete. So we talked about the size of panel. We talked about how that impacts schedule. We talked about the durability and how it will affect your maintenance cost. We talked about the ability to place stuff on the ground, and we'll get more into that. But fluidity of concrete. So this is a project in Kansas City, Missouri. It's a very simple project, consists of 3 panels. But if you'll notice that the edges are articulated, so the only thing really formed on a tilt panel are the edges. So you have this unique shape, you have this unique forming at the edge. You can see kind of some of the formwork here, and think about the craftsmanship that goes into creating these, the math that goes into the angles of making sure that those bevels or those turns kind of twisting are correct on the forms in the ground. The liner you see it's called like a shadow liner. You pour concrete over it, you remove the liner, and you end up with, well, there's the kind of some structural detailing and how that looks in there, but you end up with the image as the sun moves across it. So again, talking about low maintenance, there's 2 of them, there's one on each side. There's nothing really to maintain here. There's nothing to really fail or fade. It changes with time in the sun over a period of a day, but it's there forever. So neat project. Andrew Kudless, I don't know if, again, I'm in California here for this talk. He did teach at the California College of Arts. I'm not sure if he's still there or not. We had worked on a seminar with him looking at the architectural potential of tilt up in 2016, I think. And this is a project he did with Lake Flato in San Antonio, Texas. These are beautiful, beautiful shaped panels. They were cast on site as tilt. They were cast horizontally. So they kind of were laying down on the ground and to be cast. The formwork on the inside, here they are erecting them. There was very smooth formwork on the inside. You can see the exterior of them, or the up facing side has been affected. So they took a broom and they sweep the exterior so that as rain would fall down, it would age the panel differently on the exterior than on the interior. And the geometry is obviously very special. They had a few forms that they used, a few of the molds that they used, and they were able to just reuse them. There's a kind of an aerial shot, kind of a bad picture, but you get the idea of the composition. Here's some nice pictures of the interior of the pavilion. The Lake Flato building's kind of behind it. You can see how they're held apart there, and there's a connector there to hold them together with that space. Those holes, all of it are cast there on site, but not in place. Another view of that project. So I said they were cast horizontally, and working horizontally definitely has its advantages. We've seen it throughout this presentation, but just some specific instances where working horizontally was really the ticket to some interesting and productive moves architecturally. This is the Seawalk Performance Pavilion in Jacksonville, Florida. Again, it doesn't look like anything super spectacular, but you can kind of see the the profiles of the panels. This is a very low budget project, but they were able to make some unique moves on it to give it some character. But really what I wanted to show you was these sound attenuation elements at the back of the pavilion. So you can see them, here's just kind of a detail of them, but you see them back there. You know, those were, you know, cast into the panels by just laying down foam on the casting slab and then again pouring concrete over them. Very cost effective, but very impactful way of making it a custom kind of hand built thing. And there's lots of examples of form liners or foam kind of structures or things put down onto the slab and then concrete poured around them. So you can see these cast in. The one example I wanted to show you, this is the Margot Living Graduate Art Studios by Johnson and Mark Lee, UCLA project. They had an art studio that they wanted to relocate. They didn't relocate it. They wanted to renovate it. So that building in the center, this kind of center piece here was existing. And then this tilt structure was built around it. They used a very deep form liner. So it's a plastic form liner that lays on the ground that creates this fluted look. You can kind of see the seams. This form liner had seams. You can see those horizontally. And then vertically, it's interrupted by, well, it's not interrupted, but vertically, you can't even tell where they are, but are cast in place columns. So again, this is a California project. They do things a little unique in California. There's a variety of reasons why, but you can see the cast in place columns here, and then the cast on site tilt panels between them. So just flat in the interior, but then that fluted form liner on the exterior. So it's an interesting combination of cast in place columns with a tilted wall panel. It's fluted design. You can see how clean kind of the details get to be because there's, you know, the systems are so simple that the details are very clean. Another project where we're looking at, so Todd Williams and Billy Chen in New York had written once about their folk art museum, which is now demolished, but they wrote about how they wished they could have cast their panels on the streets of New York and just had whatever gum and wrappers and bottle caps were in the street, then kind of embedded in their walls and then lift them up. And that is the museum wall. And I had emailed them and told them, you could have done that. And we had a really good conversation about it. And they ended up working with us on a community project we did later. But this is an example of that kind of idea where you have, they were building a military training complex. They wanted to replicate cave structures. And they originally were going to use precast pipe, but it was too uniform. It was round, so the floor was round, the ceiling was round, and they didn't have the kind of cave-like atmosphere, the cave-like experience that they wanted to replicate. And so they just cast these in the dirt and picked up the dirt, and whatever it was there was there. So you can see how these ended up. They were able to vary the height. They were able to make these panels, you know, uniquely shaped so they could expand and contract. The space could expand and contract as the trainees went through it. The details again are very simple. This is again just a training facility, so it wasn't super complicated, but the result was really impressive. I'm not going to show you this video in the interest of time, but he just runs through the training facility and you see him through there. So a more kind of refined example of that is the Cloud Song Center in Scottsdale, Arizona by Architecton. This is a project where they also had a very limited budget, but they wanted to create something very meaningful for this community. It was part community college, part community center for the tribe that is there in Scottsdale, and they used the saguaro ribs to cast into the panels. So you can kind of see there's a saguaro cactus there, and they use the ribs are cast into the panels. So they laid them down on the ground in the casting beds. I think they did use sand in this one as well, so that the concrete wouldn't go in between them. You can kind of see the structural embeds being put in there around them. They cast the concrete, they lifted them up, and then they went through, and some of the ribs stuck to the forms, some of the ribs stayed in the panel. They used a shield and a torch and burned some of them out. They burned some of them and left them in. And it's this beautiful texture that they created there. They even brought it into the interior of the building where you can see there it comes into that kind of gathering space. And there you can kind of see a better view of the different textures and colors left by the ribs. Right before that project, a few years before, was a project by Studio Mall, also in Scottsdale, Arizona, the Museum of the West, where they used a similar technique, but a little bit more subtle. So they had cactus ribs that they also put in, but they, instead of just changing the density, they would cut them out in certain places to create these different textures on the walls. There you can see it's kind of a more sharp kind of vertical fin that resulted. They didn't use the sand in between them, so it gives you a kind of a, I don't know, it looks different. So a different result. That's why the mock-up panels are so important, because again, these are pieces of art. They're handmade pieces that you want to test. You know, what happens if we don't use sand? What happens if we do? What happens if we burn these? What happens if we don't? If we just take them out or leave them in? And so, very unique. Again, they brought it onto the interior as well. Super successful project. So not only can you affect the surface, you know, with these embedded or things laid down onto the casting surface, you can punch right through it. So this is a Fort Worth camera in Fort Worth, Texas, by Abanya Shaw. Here they had used the inspiration was the different aperture settings on a camera and how that lens opened up and contracted in those different settings. And they created this, the whole building is tilt, but this screen wall was the kind of piece that was very interesting for them. Here you kind of see the interior views of that. And as somebody goes through, they did it for a lot of reasons. One, they wanted a visual identity to the building that was very strong. This is a project that's just down the street from the Kimball Art Museum, you know, a super famous Louis Kahn building. And you also have Tadao Ando's Contemporary Museum, and then Renzo Piano's addition to the Kimball. So lots and lots of concrete, important concrete in this neighborhood. And Abanya Shaw did a great job there with that project. And I think I just have a couple more projects, but this is a library, again, where they use that kind of perforation technique. They also separated the panels, something that's been done for a long time, but a very nice, transparent, kind of open, airy feel to that library there. So in wrapping up, you know, we talked about a lot of the benefits. We talked about the different forms and the different finishes you can get. But one of the unique things about Tilt that has a lot of pride behind it is Lift Day. So again, I write with every project, there are milestones that are celebrated, right? Like a topping off ceremony when the top of the steel is placed. With Tilt, it's Lift Day. Often there are owners there, developers there, the architects usually there, engineers, contractors. So everybody kind of gathers to see this building be born. We hear stories all the time of people that are driving to work in the morning, there's no building there, and then they drive home at night, and oh my gosh, the building just appears. They don't see all the work being done on the ground in the meantime, but on the drive home, there's a new building there. So a lot of times it's shown as this kind of, this video is probably gonna be loud, but hopefully it's not. It's usually shown in time-lapse fashion, right? Where you've got, I'll play it. Where you've got these panels going up really fast, and it's, you know, rock music or whatever the heck this music is, and it's spastic and everything's flying around. I don't like showing them that way because it's not that way in real life. And so if you haven't been on a Tilt job site, this is much more like it. I'll turn the music down, but it's a carefully orchestrated operation. It's not fast. It's not haphazard. It's quite a beautiful thing to watch. And when you can connect this construction technology from not only the feasibility of the project, whether it can be done on time, whether it can be done on budget, but then also to its aesthetic. Looking at Stephen Hall and the way he used it, and others that I've shown you today, you know, it can really be it can really be a huge success, and there's lots of opportunity. So with that, I'm finished. I appreciate the time, and I look forward to any questions you may have.
Thank you so much, Mitch. Hold on, let me spotlight myself too as well. Okay, so first question for you. Are there CO2 negative tilt-up panels?
Lionel, are you on here?
I am.
Okay, so I'll preface whatever Lionel's going to say by the advancements in concrete technology related to sustainability are mind-blowing. And right now, there is so much more we could be doing with concrete from a design perspective. The technology exists for concrete buildings to be incredibly sustainable, but they have to be specified that way. Lionel, you can cover that better than I can, though.
Yeah, sure. In fact, the four webinars that we sponsored as part of the Climate Action Series for AIA California addressed that issue. So the webinars included the top 10 ways to reduce concrete's carbon footprint, specifying sustainable concrete, and then concrete innovations. And then finally, there was a webinar on Portland limestone cement. In those webinars, we cover all of the technologies that you can use, specify, encourage as part of a project, all of which can be incorporated into tilt-up concrete construction. I would say, Mitch, and please correct me if I'm misstating this, but the concrete used in tilt-up construction is not, I would say, in the ultra high performance range, okay? It's not super high strength. It's not even super high early strength concrete, even though it's, a schedule is important. It's not like, post-tension concrete that needs,
That's correct.
4,000 PSI in 2 days, to post-tension. And so what that means is that all these innovations that you can use to reduce concrete's carbon footprint can be used in tilt-up, probably to better advantage than a lot of, let's say, high-rise construction, where you're talking about super high-strength concretes, super compressed schedules, and so forth. So am I correct in saying that, Mitch?
That is correct. In the concrete mix, it has little to do. There are very few structural needs on the concrete mix. So the stuff you can do with the mix and tilt up can have everything to do with aesthetics, can have everything to do with the sustainability of the element. So I agree with you. Really, when you think about concrete and sustainability, it's almost, I think it parallels the issues or the conversation we're seeing about investing in Mars versus investing in Earth. Concrete is the most widely used material for a really good reason, just like we're on Earth for really good reasons. And it's going to be more efficient for us to fix Earth than to move to Mars. And it's going to be more efficient for us to improve concrete than to find some other material that's going to take its place, because it's just impractical in a lot of ways. The opportunities, any advancement you can make in concrete is going to have broad implications versus advancements in some other kind of obscure application or obscure material. So I think the opportunity to do good in concrete is huge. And if you all would spend some time taking a look at NRMCA's webinars, looking at the incredible technology that's already out there to improve the sustainability of concrete, you'll see huge improvements very quickly. It's ready to go.
Thank you so much, Mitch. I will actually include all of the links to the webinars that Lionel mentioned on the follow-up email, so everyone has access to those. One more question before we wrap things up. How much does the engineering of the slabs and reinforcing differ between factory precast and the site cast methods? Okay,
so the big difference is site cast or site cast precast or tilt up is not post tension. So you're going to design using the ACI slender wall method. as if it were cast in place. The engineering is not going to be affected by the lifting process. So the lifting engineering is done by a third party, whether it's whoever's designing the lifting and bracing for the panels, they would design the panels for lifting. The engineer on this project, the engineer of record would design for in-place loads, no different, using the slender wall method, no differently than if it was cast in place. If it's a precast product, that's a pre-engineered product that's going to be post-tensioned. So they're different in that way. I hope that answers your question. If not, I'm happy to try to answer it more clearly.
I can connect you after the fact if need be. So with that, I just want to give a big thank you again to Mitch and to our MDC presenting partners, Build with Strength, NRMCA, CNCA, CalCIMA, and CalCIMA for this excellent presentation. If you've made it this far, AIA California staff will submit you for your AIA continuing education credit, which should appear on your transcript within the next few weeks. As we mentioned in the beginning, AIA California is hosting more partnered webinars all week through our Monterey Design Conference University, and I will share information on the remaining sessions after today's webinar. And thank you again, Mitch. Thank you everyone for joining us, and we will see you all on our next webinar.
Thank you very much.
Thank you.